Imagine, if you will, a journey not bound by the limitations of space and time. Picture for a moment a reality where the past, present and future coexist, where the laws of physics are no more than mere suggestions. This is the realm of time travel, a concept that challenges our understanding and shakes the very foundation of what we perceive as possible. It's a journey filled with intrigue, a voyage into the unknown. The question isn't whether we can travel through time, but how. Join us as we unravel the mysteries of time travel in the next few minutes. Ever heard of Einstein and his theory of special relativity? Now, this was a man who knew a thing or two about the universe. He proposed that as an object moves faster and closer to the speed of light, time starts to slow down. Yes, you heard it right. Time, that unstoppable force, bends to the will of speed. Imagine strapping yourself into a rocket that can zoom close to the speed of light. As you buckle up and brace for the journey, on Earth, your friends, family, and the world as you know it continue to age at a normal rate. But for you, inside your high-speed vessel, time would tick away much slower. Einstein's theory might sound like something out of a science fiction novel, but it's not just theoretical. It's been proven right here on Earth with atomic clocks, the most accurate timekeepers we have. In one experiment, scientists placed atomic clocks on jet planes and flew them around the world. When the planes landed, the atomic clocks on board were slightly behind those that stayed on the ground. This time, difference, as minuscule as it was, confirmed Einstein's theory. Time indeed slows down as one moves at speeds close to the speed of light. But before you start dreaming of hopping into a light-speed rocket to the future, let's bring you back to reality. Despite its tantalizing promise, reaching such astronomical speeds is currently beyond our technological grasp. We're talking about a velocity so colossal that it's about 700 million miles per hour. That's like circling the Earth over 27,000 times in a single second. So while Einstein's theory of special relativity gives us a fascinating insight into the nature of time and space, it's not yet a practical route for us to explore the future. While it's fascinating, reaching the speed of light remains an impractical method for us to venture into the future. But don't lose heart. The universe is full of mysteries, and who knows what other time-bending secrets we might uncover in our cosmic backyard. Gravity, an unseen force that holds us down, but could it also slow down time? These words may sound like the beginning of a science fiction novel, but this is a question that scientists have been grappling with for years. And the answer, according to Einstein's theory of general relativity, is a resounding yes. You see, according to this groundbreaking theory, gravity isn't just a force that keeps us from floating off into space. It's a fundamental element of the universe that can bend and warp the fabric of space-time itself. In areas where gravity is particularly strong, time actually moves slower. It's like walking through thick mud. The stronger the gravity, the slower time seems to move. But this isn't just theoretical mumbo-jumbo. This phenomenon has been observed in real-world experiments. Atomic clocks, the most accurate timekeepers in existence, have been used to test this theory. In one experiment, 2 atomic clocks were synchronized. One was then placed at a higher altitude, where gravity is slightly weaker, and the other was kept at sea level. After a period of time, the clock at the higher altitude was slightly ahead of the one at sea level, demonstrating that time had indeed moved slower in the area of stronger gravity. This effect, while minuscule on Earth, could have profound implications for time travel. Imagine a planet with gravity so strong that a single hour on its surface equates to a year back on Earth. A short vacation could allow you to leap forward in time, witnessing the future unfold. But before you start packing your bags for a gravity-induced time travel trip, it's worth noting that we're still a long way from turning this theory into a practical reality. The gravitational forces required to significantly slow down time would be immense, far beyond anything we currently have the technology to create or survive. Gravity, as we see, has a much deeper impact on time than we could have ever imagined. So while we may not be ready to harness the power of gravity for time travel just yet, one thing is for certain. Our understanding of the universe and our place in it is constantly evolving, and who knows what exciting discoveries the future may hold. What if we could put life on pause? Imagine being able to freeze time, to halt the relentless march of seconds, minutes, hours. This is the concept of suspended animation, a tantalizing theory in the realm of time travel. Suspended animation is not a fantastical concept conjured from the depths of science fiction. It is in fact a phenomenon we can observe in the world around us. Consider bacterial spores, those hardy microorganisms capable of surviving in extreme conditions. When the environment becomes too harsh, they enter a state of suspended animation, effectively pausing their life processes until conditions improve. Once the environment is favorable again, they resume their life processes as if no time has passed at all. In the animal kingdom, we see this remarkable ability in hibernating animals. Think about a bear settling in for its long winter sleep. Its heart rate slows, its body temperature drops, and it enters a state of suspended animation. Throughout the cold winter months, the bear's life processes are slowed down, preserving its energy until spring arrives. Translating this natural phenomenon into a method for human time travel is the next frontier. Imagine if we could slow down or even halt our bodily processes. We could travel long distances in space, embark on journeys that would take generations, or simply pause time while we gather our thoughts. But as with any frontier, there are challenges to overcome. How do we safely enter and exit a state of suspended animation? How do we ensure that our bodies can survive the process? How do we control the duration of our time in this state? These are the questions that scientists are grappling with as they explore this promising avenue of time travel. Suspended animation, a realistic approach to time travel with current technology, yet the journey to perfecting this method is far from over. This is the essence of exploration, the thrill of stepping into the unknown. The quest for knowledge continues, and with it, our journey through time. Wormholes and spinning cylinders of light sounds like science fiction, doesn't it? But in the world of theoretical physics, these concepts are at the cutting edge of our understanding of space-time and the tantalizing possibility of time travel. Imagine a wormhole. It's not a worm burrowing through soil, but rather a theoretical tunnel or shortcut, predicted by Einstein's theory of general relativity that links two distant points in space-time. It's like folding a piece of paper in half and poking a hole through it. The hole, or wormhole, provides a quick route between two far-off spots. But there's a catch. Wormholes are believed to exist only at the quantum scale, and scaling them up for human-sized travel is a massive challenge. Now let's turn to a completely different concept, a rotating cylinder of light. This idea was proposed by American physicist Ron Mallett, who suggested that a rotating cylinder of light could spin space-time itself. And if space-time is spinning, then just as ice skaters can travel in a straight line by picking a point on the spinning ice and moving towards it, we might be able to pick a point in space-time and move towards it too, potentially even a point in the past or the future. However, Mallett's theory has faced skepticism. Critics point out a small flaw in the basic model, which makes practical implementation a far-off dream. But don't let that dampen your spirits. These ideas, wormholes and rotating cylinders of light, are pushing the boundaries of our understanding of the universe and time itself. Although these methods remain largely theoretical, they open up exciting possibilities for the future of time travel. As we journey back from our exploration of time, we carry with us a treasure trove of insights. We've delved into the mysteries of traveling at near light speed, felt the inexorable pull of gravity's grip, and explored the realm of suspended animation. We've marveled at wormholes, those tantalizing shortcuts through space-time, and pondered the power of manipulating light,